Hi everybody, welcome back. Today on the bench we have a neat Hewlett-Packard voltmeter. It's a 427A. It's a multimeter that can be powered by power cord through the line, but also can operate with battery and should be pretty useful if it will work, of course. We don't know the condition. It has been sold as untested, and everybody know what that means. Everything can be inside. I will give a very quick outside cleaning, and I will remove all the panels, and I'll be back. After a very quick cleaning and the instrument opening has immediately revealed the presence of the battery. And moreover, when I was moving the function switch and the instrument place it on its rear, we can see that the needle move a little bit. So I think there is a very low residual voltage into the battery. So I'm going to remove and see which kind of battery is inside, which seems to be an ever-ready 663, and probably is 22.5 volts. Let's see. Well, actually it's just a foam. I was imagining that the battery was inside, just a thick foam. So what I've seen moving probably is a residual charge onto the capacitors, which is good. But I can't see the battery wiring. So I think I need to make some research onto the service manual. Let me remove also the bottom cover. Well, inside is pretty clean, and I wonder if the instrument actually works. Let's make some tests and see how it works. Meanwhile, I'm just realizing that we have a minus and plus here. So probably there should be a sort of connector. I don't know if it was supposed that the battery terminals are coming through these holes. I really don't know. Well, actually, it has been simpler than expected. The two wires should have been soldered onto the battery switch, so has been removed, and we don't have any battery plugs. But this is not really a problem. We can manage a battery pack later on. Let's test the voltmeter as is. As I don't know when it has been powered up last time, I'm going through the dim bulb and variac. The instrument is set for 230 volt, and I'm plugging. It's already plugged. The variac is at 0, and the needle has already moved and rising up. The voltage doesn't make any big change. I'm at 100 volt. I've placed terminals here, these two wires, and they are shorted together. So we should have a meter that goes up, and it doesn't. Don't know if it's a matter of voltage. Let's raise up more. We are at 150 almost. I don't think it's a perfect functioning instrument, because I would imagine that even with a lower voltage, the battery should indicate a bit more. I believe that should also indicate the power supply voltage. But in any case, on 2 ohms, we have no change here, no change there, or very little, and moreover, no change moving the adjustment. By the way, no smoke, no magic smoke, so seems safety enough to rise up more. 170, 100, okay. Okay, we are having some reaction now. Okay. So probably we are going to see better results. Not yet working, and this stand really doesn't hold. And let's see. Oh, that is pegging the meter to the limit. Yeah, and indeed we have our voltage should be at least 1.5 volt. So it seems already enough, but the instrument is pushing to the extremes. So probably we are facing some problem. So let's go for full power and see how it behaves. Okay, I'm at full power. No dim bulb, so straight to the line. Okay, we have 185 volt indication, but we still have this problem with the meter, so it's pushing the needle to the limits. No matter if I place in a higher range, no way to see. Okay, on AC it's a little bit better, and we are able to zero. Not exactly a zero, but I don't know if there is something wrong with. Need a troubleshooting. Well, another test that I want to perform is with an external DC power supply. Here we have 23.8 volt. So the 22.5 volts seems to be exact. And yeah, I will apply an external power supply, so we will see feeding with pure DC how the instrument behave. I'm applying 19.5 volts. I want to stay in the low side, but I'm having the same problem, and that was totally expected. And we don't have any reaction, so there must be some problem into the circuit. I've printed out the schematic, and the first thing that I've noticed is that from the battery or the line, and my printer this morning doesn't want to cooperate, it generates plus and minus 6.7 volt, and here we have the ground reference. So I think that the first step will be to check that those voltages are present and correct, and move from there. Well, I think there is something weird into the manual, as it is required to first adjust the amplifier balance and then the voltage regulation, which is a bit odd to me. However, I have checked the two voltages. We have plus almost 7, 6.94, and the minus side is minus 6.6. So there is a 0.3 of offset and or unbalancement, if you will. So I want to try to move and let it be more balanced, if it's possible, and that should be done with this. Let's see if it moves. Yeah, actually it doesn't move at all. Let's see onto the negative side. Yes, doesn't move at the same. So probably this regulation, it only affects the circuit that are fitted. So let's try to make the calibration. Well, I've tried to move the adjustment all the way around. No movements, no change, and the meter needle is pegged onto the limits. So at this point, I need to figure out where this problem comes from. And here we have our meter. Let's see if I can. Okay. This is our meter, and it seems that here we have the meter, and here is the meter AC circuit, which seems to be working. So we have a problem probably into the DC section, and yeah, let's see which kind of voltage we have. Well, reading a little bit better the service manual, there is a very handy guide to troubleshoot the meter, and it seems that if both ohms and DC are pegging the meter, it means that the DC amplifier doesn't work properly. So there is a guide, and it seems that this DC amplifier is a unit gain. So we should have, if we apply 1 volt at the input terminal, we should have 1 volt at the output of it. So let's see if we can make a setup in order to have this condition. So yeah, let's do that. Okay, I'm applying 1 volt with my 6111A DC power supply. So it is required to place the meter onto 1 volt range and to measure the output at pin 8 of the board itself. The meter is pegged to the limit, so let's check pin 8, and we should see 1 volt, and let's see, and we have minus 3.4, so we have a problem here for sure. Well, it has been written onto the manual to check the voltage across Q9, and I'm having all 6.9 volts as on TP1. That should be 3 volts. So I'm afraid that we have a shorted transistor over here, and there is no way that I will fix the problem with my light. So here we should have 3 volts, so we have complete 6.9 volts. And I believe this transistor is not working at all. So, but could also be that here we have a problem. So yeah, let's continue the voltage checks. Well, nothing of what I've done so far gives me a clue. However, unfortunately, I said my printer doesn't help this morning. But if I short the input, I shouldn't have any voltage onto the input of the DC amplifier board. I have a shorting bar onto the terminals here, right across the holes. But I still have, if I switch on, minus 3.2 volt. That is pretty weird. It seems that we miss the ground connection, the ground path. Now the common, it's going to the metal here through this riveted piece. So let's try to move this, see if we have some difference. We don't. We have a separate ground between input and the chassis. So also the DC amplifier board has a separate ground relevant to the metal enclosure. And yeah, let me try to trace where it goes and if we have continuity. Or perhaps we have a broken resistor here, 10K, don't know. Or maybe something else into the path. Let me try to figure it out. So the ground path, it's okay. I'm measuring between the common binding post to the board ground, and we are having a short, so that's okay. Well, I think I found something. I'm measuring continuity between the input binding post, the positive side, and the input of the board. We have very high resistance, and it's going to charge capacitors, but actually we should have some fixed resistor onto the path. So let me try to figure it out which kind of resistor we have. I do see two 400K resistors plus one, but this is on the, onto the DC path. So perhaps we have a problem there. Let's try to find those. Well, I found the 10K resistor and it's measuring fine. So no problem with that. Okay, then I think I've got the wrong test point. I should measure over here to see the input voltage. So I think that everything done so far, it's wrong. So let's apply again the 1 volt required and see how it behaves. And we have 1 volt. And if I switch onto here, we are going to have 1 volt, but clearly here it's completely off. So the problem at this point may lies indeed onto the board itself. Well, I started to remove the transistor, the FET, which is the impedance converter over here, and it's fine. But then I measured the voltage across this capacitor, And I'm connected to the relative ground. And if I measure the plus, it should be at plus 6.7, which is higher, as we know. But if I measure at negative side, it should be at ground. And we have 6.6. So it seems that this capacitor is not grounded over here. This is C5. Right there. There must be something wrong onto the board. It seems that we have a lack of ground. I believe the ground path it's made by the screws. Maybe there is something wrong there. Let me try to figure it out. Well, it seems that my instrument differs from what inside this manual. Indeed, we have the manual part number is 004279005, and it seems that the one that should cover this instrument should be 9008, which is pretty difficult to find online. And the board itself has 66511, whereas the manual is covering the 66,501. And it differs, this capacitor is different, the input signal different, and indeed on to the other board, the A2 board, it's missing one pot, and it seems that a newer revision include the omission of that. So, by the way, while I will try to find the proper service manual and schematic, I've removed this capacitor and tested. It seems a bit leaky, so I want to give a proper fresh capacitor and make other tests. The transistors themselves, they appear to be fine by diode checking in circuit. So doesn't mean that they are fine, but at least let's start from capacitor. They always give problems. Okay, what I've done is to replace the capacitor with a non-polarized one, 10 microfarad 50 volt, as it's floating between two voltages. Shouldn't be an error. So let's see how it behaves. So battery still fine. Oh, would you look at that? It is not pegging the meter now. So let's see. And now is also able to adjust the zero. There is a dirty pot here. So let me try to apply 1 volt. We might have found our culprit. Let's see. So let's place 1 volt. Oh, perfect. I think it's fixed. Wow, that is very nice. So let's make an additional test. Place the capacitor in a better position and definitive, and let's see if we can proceed with the instrument calibration. The restoration has required the removal of the front glass of the meter, and luckily I was able to save the seal over there. So the glass itself, it's pretty foggy. It's not visible on camera, but it's pretty foggy and dusty. So I want to make it pretty clean, and this will make the instrument pretty nice. Okay, then the instrument is fully calibrated, and it went pretty perfect, spot on. no problem. The balance, it's perfect on the three ranges here. When I switch onto AC, we have this needle movement as many of those instruments do, but it's measuring perfectly fine. So pretty happy with the result, and I believe I will make another video. Oh, by the way, I found the reason why it doesn't hold the stand here, because it was missing this foot. But as this instrument have both feet, front and rear, so I have removed the rear one and I have the front one here. And as you can see, I have other meters. This is a power meter. I don't have the I have two power sensors, but they are faulty, and this one is faulty as well. The needle is moving crazy, and I believe we have a problem. So I'm pretty happy with the result of this, and in the next videos I will try to attempt to repair this one first, and perhaps also this one. So I thank you very much for watching, and I'll be back soon.